Hello everyone, today we'll be finding the term independent of x in these binomial expansions. Now a term independent of x means we want to get a term that does not have an x in it. Now there are two ways to find this particular term. One way is to expand this binomial in full. But this method is long and tedious. So another way, which is much faster, is to make use of the general term in the binomial expansion. In the expansion of a plus b power n, where n is a positive integer, any term within the expansion takes this format of the general term. Now do take some time to remember it. Now let's apply this to question 1a. For this expansion, let's try to find the general term. Now since the power is 10, we have 10r, x cubed 10 minus r, minus 2 over x squared power r. Now always bring along this negative sign which is in front of the terms. Now at this point, let's bring our attention to all the terms of x. Expand the expression by removing all the fractions. We will then have x power 30 minus 3r, followed by minus 2 power r, and since x squared is at the denominator, we're going to convert it to a linear form of power minus 2 power r. Now the idea here is to then group all the terms of x together using the laws of indices. Now for the term independent of x, simply equate this power to 0 because any term to the power of 0 gives us a 1. And this kind of eliminates the x within the term. So r is actually 6 when we solve for this equation. With this value of r, let's substitute it back into the general term. Thus, the term independent of x is equals to 13440. Now let's try 1b to solidify our understanding. Again, instead of expanding everything in this binomial expansion, simply get the general term of the binomial expansion, which is 15r x squared power 15 minus r, and you have a fraction over here, minus 1 over 2x cubed power r. We will then expand the expression to give us 15r x power 30 minus 2r. Now this expression here is a little tricky to separate. Let's have a look at how it is done using the red demarcation on the working. Now grab the minus sign with the 2 in the denominator and don't forget to take the power r along with it. Now in the next step, simply write x power minus 3 with an r outside. Now with this format, it is then very easy to group or combine the bases of x together using the rules of indices again. That is, if you are multiplying terms of the same basis, add the powers together. Again, the idea here is to then use the power of x to equate to 0. Since the term independent of x, the power of x is 0. Now with that, r is again equals to 6. By substituting r equals to 6 into this general term, the term independent of x is therefore 5005 over 64. Now how about the last example over here? Now we want to get the constant term. Now the term independent of x is also called the constant term. Since it does not have a variable in it, it's like a synonym for an independent term. Again, the method here is to get the general term first. Now expand and then group all the x's together. Equate the power of x to 0 to get r. And then substitute this value of r back into the general term so that we can get the constant term, which is 240. Now I do hope you have learned something from this video. If you have any questions or comments, do leave them down in the comments box below, and thank you so much for watching.